Greetings everyone. I, Muhammad Aqil Naufal bin Muhammad Amer, metric number AF190210, will present about the introduction of our project. Anchored retaining walls are often associated with ground stabilization, and its innovative procedure is mainly aimed at reinforcing or consolidating the adjacent ground and making the work permanent. The principal characteristic of a retaining wall is being able to withstand the pressure exerted by the retained material, which is usually soil. They are used to bounce soils between two different elevations, often in areas of terrain possessing undesirable slopes or in areas where the landscape needs to be shaped severely and engineered for more specific purposes like hillside farming or roadway overpasses. The concrete can be projected directly onto the site with the cells after the site with the geotextile covering has been installed on the ground or embankment to create drainage and thereby reduce hydrodynamic thrust. A drainage system recovers and evacuates the water that has infiltrated the embankment from the bottom. It is important to have proper drainage behind the wall in order to limit the pressure to the wall's design value. Drainage materials will reduce or eliminate the hydrostatic pressure and improve the stability of the material behind the wall. Dry stone retaining walls are normally self-draining. Then the literature review. Anchors are versatile and practical form of earth retention. Over the years, the technique has been successfully deployed all over the world to tackle the challenge of unstable embankment and to provide stability for slopes generally. The main purpose of ground anchors is to prevent horizontal movement while stabilizing retaining structures, along with preventing additional movement to existing retaining walls or bridge abutments. Ground anchors can carry very high loads to hold down, up, back structures and slopes. In 1979, the U.S. Department of Transportation Federal Highway Administration, also known as FHWA, Office of Technology Applications, authorized a permanent ground anchor demonstration project. The objective of the project was to provide highway agencies with adequate information to promote routine use of permanent ground anchors and anchored walls.
Techniques of slope stability. The best choices of techniques to remedial the slope failure according to the given case are retaining structure and drainage methods. Drainage method increases the weight of the soil, making up the slope. This makes it more vulnerable to mass soil movement. This method also helps to reduce the cohesion between the particle grains that make up the slope, making it less resistant to movement and increasing the likelihood of soil liquefaction. Furthermore, water runoff on slopes contributes to erosion while below ground, exerting pressures that supporting structures may not be able to withstand. The drainage system design is capable of efficiently channeling waterway from the slope without affecting slope stability or causing erosion. Weep holes in retaining walls and French drains are two popular drainage methods. Saturation and poor water pressure buildup in the subsoil are two of the slope failure factors. If a drainage system had been installed, the chances of poor water pressure and subsoil saturation would be reduced. This method has the potential to be very effective. Surface drains are simple to maintain, but subsoil drains are more difficult. Subsoil drains are commonly found in retaining structures as weep holes and cut-off drains. In most cases, this method is used in conjunction with others. The surface drains was mostly used with the geometrical method, whereas the subsoil drain is a part of a method combined with the retaining structure. To avoid the effects of large amounts of water absorption by the slope, surface drains can discharge more water, especially during heavy rain. It is common to see three or more slope repair techniques being used together to address the unique characteristic of a particular slope. Therefore, along with drainage method, we are using retaining structures. This is due to stabilize the slope surrounding the area. Retaining walls are walls that are designed to retain or hold in place a substantial amount of soil. Retaining walls are often classified in terms of their relative mass, flexibility, and encourage conditions. In this case, we are using anchored retaining wall. Anchored retaining wall is the type of retaining wall is employed when the space is limited or thin retaining wall is required. It is suitable for this case as it is for loose soil over rocks. Considerably high retaining wall can be constructed using this type of retaining wall structure system. Deep cable rods or wires are driven deep sideways into the earth, then the ends are filled with concrete to provide anchor. Anchor are known as tiebacks, act against overturning and sliding pressure.
As for the introduction of my topic today, over the years, JKR had been involved in the design and construction of slopes, especially in road construction in terrain. The design of road was usually based on the conventional techniques of balancing cut and fills with the slope gradient of 1V to 1H to 1V to 1.5H for the cut areas of 1/2 for the filled areas. Landslide records for years 1966 to 2003 shows that 42% of landslides occurs in hilly terrain areas and more than 90% occur in developed areas. The objectives on guideline for slope design is: number 1, to stipulate guiding principles to JKR and other engineers involved in slope design to minimize risk in slope failure disaster, to increase stability of slope, and to further enhance existing geotechnical requirements for slope design. The design responsibility is to gain a complete grasp of the issue that may affect the work. The designer must seek and analyze all paper on feasibility studies, development plans, and investigation linked to the works. Regardless of the standard outlined below, the designers must meet the aspects 16 of aesthetics, functionality, and safety, as well as the sustainability and effectiveness in order to accomplish the job to the intent of the works. For the survey data and site investigation, the designer shall carry out detailed topographical, hydrological, and land surveys of the proposed site and areas that may be affected by the works, which may be necessary to supplement available survey information for the satisfactory execution of design and construction of the works. Survey plans shall be prepared in scales appropriate to the purpose and follow guidelines for presentation of engineering drawing. Next, the design data and soil parameters. All geotechnical design features must be based on data interpreted from the preliminary SI report and any subsequent soil investigation conducted by the designer. The report of the result of field exploration and laboratory inquiry must be included with every detailed design, such as the 5 notes below. Next, on slope stability. Slope stability analysis, including establishing design criteria and performing calculations, will be required for all cut, field, and natural slopes. The data to be utilized in the slope stability analysis shall be on detailed site plans, detailed field descriptions, on-site exploration data, and laboratory task data. Slope stability analysis shall include stability analysis for the temporary stability measured during construction, cut and fill slope stability analysis, and any slope that is influenced by surcharge load. Finally, for drains. Surface drains in slope faces shall be provided in addition to normal cut-off drains at the top of the slope. Downslope surface drains shall be provided for all cut and fill slope surfaces. The drain shall be cascaded drain with handrail for ease of maintenance in the future. And for the subsurface drains, such as horizontal drains and drainage blankets, shall be provided for cut and fill slopes and for areas where the groundwater level is found to be high. That's all from my part. Thank you.
For the long-term stability, the use of anchors into a structure's rock foundation is allowed for faster construction and lower cost, reduce the size of excavation, which is important when roads and engineering pipelines are nearby, and provided structural stability in situations where traditional methods were difficult to or impossible to solve due to the weight of the structure or soil. As we all know, anchored walls are one of the most cost-effective earth retention systems. An anchor, as the name implies, is wrapped around the wall and has a base that extends deeper into the hill, providing stability. So the overall stability of the anchored wall, soil slopes above and below the anchored wall, access roads, excavations, and working fields, all of which are conditioned by the building method, must be verified. The geo-limit state in retaining or supporting structures usually takes into account the following factors: ground-bearing capacity, determination of earth pressures and activated resistances, external resistance of ground anchors, and so on. It is the area concerned with the importance of soil and the rock strength in ensuring resistance. Next, sufficient bearing resistance of cross-sections of structural elements must be addressed and confirmed in retaining support structures with the STR limit state, including tensile, compressive, flexural, and torsional loads. The limit state refers to a structural element's internal failure or excessive deformation where strength prevails in the bearing resistance verification. Next is the HYD limit state. Takes into account the status of ground failure in the retaining or supporting structure, influence region due to exceeding hydraulic gradients in areas where soil or rock strength is critical. When the ground water is filtered upwards in front of the retaining or supporting structure, as well as in any circumstances where the groundwater levels in front of and behind the structure differ, the HYD limit state must be investigated. When verifying ultimate limit states in anchored walls or all cases where the structural stability is dependent on passive resistance in front of the structure, it is necessary to reduce the design ground level by a value A, which shall be equal to 10% of the distance between the lower support and the ground.
As a conclusion, soil has always been important to humans from the dawn of time till the present day. Soil is closely linked to the area of civil engineering, as engineers work with it in a daily basis. Although certain clays became solid when a certain amount of power is applied, Malaysian clays do not. It has low strength, a low yield stress, a high compressibility and a low permeability, making it a poor construction soil. To geotechnical engineers, clay is a difficult soil that causes problems in any structure, such as subgrade problems due to unwanted engineering qualities. As previously said, soil plays a significant role in our construction process. As a result, it is critical that the soil meet up requirements for load bearing. We investigated potential issues about soil as well as the causes of each issues. We've also looked into the problem-solving techniques that can be used to solve such issues. Thank you.